The world has persisted many a long year, having once been set going in the appropriate motions. From these, everything else follows. Lucretius. In the beginning, about 13.7 billion years ago, all the space and all the matter and all the energy of the known universe was contained in a volume less than 1/trillionth the size of the point of a pin. Conditions were so hot, the basic forces of nature that collectively described the universe were unified. For reasons unknown, this sub-pinpoint-sized cosmos began to expand. When the universe was a piping hot 10 to the 30th degrees and a youthful 10 to the minus 43 seconds old, before which all of our theories of matter and space break down and have no meaning. Black holes spontaneously formed, disappeared, and formed again out of the energy contained within the unified field. Under these extreme conditions, in what is admittedly speculative physics, the structure of space and time became severely curved as it gurgled into a spongy foam-like form. During this epoch, phenomena described by Einstein's general theory of relativity, the modern theory of gravity, and quantum mechanics, the description of matter in its smallest scales, were indistinguishable from one another. As the universe continued to expand and cool, gravity split from the other forces. Quickly thereafter, the strong nuclear force and the electroweak force split from each other, which was accompanied by an enormous release of stored energy that induced a rapid 30 power of 10 increase in the size of the universe. The rapid expansion of the universe, known as the epoch of inflation, stretched and smoothed out the cosmic distribution of matter and energy so that any regional variation in density became less than 1 part in 100,000. Continuing onward with what is now laboratory-confirmed physics, the universe was hot enough for photons to spontaneously convert their energy into matter-antimatter particle pairs, which immediately thereafter annihilated each other, returning their energy back to the photons. For reasons unknown, this symmetry between matter and antimatter had been broken, which led to a slight excess of matter over antimatter. For every billion antimatter particles, a billion plus 1 matter particles were born. This asymmetry was small, but really, really important for the future evolution of the universe. As the universe continued to cool, the electroweak force split into the electromagnetic force and the weak nuclear force, completing the 4 distinct and familiar forces of nature. While the energy of the photon bath continued to drop, pairs of matter-antimatter particles could no longer be created spontaneously from the available photons. All remaining pairs of matter-antimatter particles swiftly annihilated, leaving behind a universe with 1 particle of ordinary matter for every billion photons, and no antimatter. Had this matter over antimatter asymmetry not emerged, the expanding universe would forever be composed of light and nothing else, not even astrophysicists. Over a roughly 3-minute period, protons and neutrons assembled from the annihilations to become the simplest atomic nuclei. Meanwhile, free-roving electrons thoroughly scattered the photons to and fro, creating an opaque soup of matter and energy. When the universe cooled below a few thousand degrees Kelvin, about the temperature of fireplace embers, the loose electrons moved slowly enough to get snatched from the soup by the roving nuclei to make completed atoms of hydrogen, helium, and lithium, the 3 lightest elements. The universe is now, for the first time, transparent to visible light, and these free-flying photons are visible today as the cosmic microwave background. Over the first billion years, the universe continued to expand and cool as matter gravitated into these massive concentrations we call galaxies. Between 50 and 100 billion of them formed, each containing hundreds of billions of stars that undergo thermonuclear fusion in their cores. Those stars with more than about 10 times the mass of the Sun achieved sufficient pressure and temperature in their cores to manufacture dozens of elements heavier than hydrogen, including elements that compose the planets and the life upon them. These elements would be embarrassingly useless were they to remain locked inside the star. But high-mass stars fortuitously explode, scattering their chemically enriched guts throughout the galaxy. After 7 or 8 billion years of such enrichment, an undistinguished star was born in an undistinguished region of an undistinguished galaxy in an undistinguished part of the universe, the outskirts of the Virgo supercluster. During the formation of this star system, matter condensed and accreted out of the parent cloud of gas while circling the Sun. The gas cloud from which the Sun formed contained a sufficient supply of heavy elements to form a system of planets, thousands of asteroids, and billions of comets. For several hundred million years, the persistent impacts of high-velocity comets and other leftover debris rendered molten the surfaces of the rocky planets, preventing the formation of complex molecules. As less and less accretable matter remained in the solar system, the planet's surfaces began to cool. The one we call Earth formed in a zone around the Sun where oceans remain largely liquid in form. Had Earth been much closer to the Sun, the oceans would have vaporized. Had Earth been much farther, the oceans would have frozen. In either case, life as we know it would not have evolved. Within the chemically rich liquid oceans, by a mechanism unknown, there emerged simple anaerobic bacteria that unwittingly transformed Earth's carbon dioxide-rich atmosphere into one with sufficient oxygen to allow aerobic organisms to emerge and dominate the oceans and land. These same oxygen atoms, normally found in pairs, O2, also combined in threes to form ozone, O3, in the upper atmosphere that protects Earth's surface from most of the Sun's molecule-hostile ultraviolet photons. The remarkable diversity of life on Earth, and we presume elsewhere in the universe, is owed to the cosmic abundance of carbon and the countless number of molecules, simple and complex, made from it. How can you argue when there are more varieties of carbon-based molecules than all other molecules combined? But life is fragile. Earth's encounters with large, leftover meteors, a formerly common event, wreak intermittent havoc upon the ecosystem. A mere 65 million years ago, less than 2% of Earth's past, a 10 trillion ton asteroid hit what is now the Yucatan Peninsula and obliterated over 70% of Earth's species of flora and fauna, including dinosaurs, the dominant land animals. This ecological tragedy pried open an opportunity for small surviving mammals to fill freshly vacant niches. One big-brained branch of these mammals, that which we call primates, evolved a genus and a species, Homo sapiens, to a level of intelligence that enabled them to invent methods and tools of science, to invent astrophysics, and to deduce the origin and evolution of the universe. Yes, the universe had a beginning. Yes, the universe continues to evolve. And yes, every one of our body's atoms is traceable to the Big Bang and to the thermonuclear furnace within high-mass stars. We are not simply in the universe, we are part of it. We are born from it. One might even say we've been empowered by the universe to figure itself out. And we've only just begun. I'm Neil deGrasse Tyson, astrophysicist and the Frederick P. Rose Director of New York City's Hayden Planetarium. Keep looking up.
So you spin, when you spin pizza dough, it kind of flattens out.
Yeah.
Gets wider in the middle. And so Earth, throughout its life, even when it formed, it was spinning. And it got a little wider at the equator than it does at the poles. So it's not actually a sphere. It's oblate. And officially it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good word. It's like pear-shaped. 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 Pear-shaped.